I'm Anil Kumar sharing with you a question from my subscriber. Let me thank all the subscribers for participating actively, answering and posting questions. And I hope solution of this will help many other viewers on my YouTube channel. The question here is, find the absolute maximum and absolute minimum for the function f of x equals to absolute value of x squared minus 16, where x is in closed interval from minus 10 to plus 10. So if you have a continuous function within a closed interval, then you will definitely have an absolute maximum and absolute minimum. So for absolute functions, it's a good idea to define them, right? So we'll define our function f of x first and then find derivative of this particular function. It is x squared minus 16 absolute value. Let me also sketch it here on the right side. It helps to understand why we have defined it like that, correct? Now if you look into the graph of x squared minus 16, the inside part, it is a parabola which opens up with zeros at plus minus 4, right? So it'd be kind of a parabola like this, right? So that is the inside function. Now when you do absolute value, in that case everything becomes positive, so the negative part flips over the x-axis and what you get is something like this. So our graph is in this portion, which is from minus 4 to plus 4, has been negative of x squared minus 16, and rest is same. Do you realize that part? We do have now sharp corners, you can say cusp, at minus 4 and plus 4. So the function is not differentiable at these 2 points. Perfect. Now these are very important things to understand when you sketch this curve. This curve as such is very important from test point of view. So we could define this as now in 3 intervals. So let me define it in 3 intervals. The first one is when x is less than minus 4. So if x is less than minus 4, in that case we see it is same as the original function, which was x squared minus 16. If x is between minus 4 and plus 4, in that case it has been flipped, so it will become negative of what it was. Let me write down this as negative x squared plus 16. If x is greater than 4, if x is greater than 4, then it is same as the original function, which was x squared minus 16. So I hope this part is absolutely clear. Now the idea is you could include minus 4 in either of these intervals. So let me take it in the center part. So now the function is continuous in the whole domain. Do you see that? Now for finding maximum or minimum, what we need to do, we need to find the derivative and find critical points. So now next step is to find critical number rather. So when I say critical number, I'm only finding the x value. So critical number is when the derivative is either 0 or it does not exist, either of these two, correct? So you can see that it does not exist at minus and plus 4. Those are the corners. And from this definition, since minus 4 plus 4, you cannot approach from both the sides. Do you see that? If you see one leg, you're looking into the other part of it, and the tangent is not same, so it is not differentiable at minus 4 and plus 4. Okay. So let's find the derivative of this function now. So derivative of this function will be, so we'll write the derivative in each piece. That'll be simpler for us to work with. So here it will be 2x, correct? So it is 2x when x is less than minus 4. And in this case, it is minus 2x. When x is between minus 4 and plus 4, we are including both limits in the center portion. And it is equals to plus 2x when x is greater than 4. Correct? Now, when are they 0? That is what you have to figure out. Now you can clearly see that in either case the derivative is not defined. So we know that the derivative does not exist at x equals to plus and minus 4. Right? Those are the corners. When is it 0? F dash x is equal to 0 at x equals to 0. Now x equals to 0 is in the center arm, right? So if I write 0 here, I do get a 0. So that is when the derivative of this function is 0. Now to find absolute maximum and minimum, what do we need to do? So algorithm is that first thing, the function should be continuous within the given interval. And second thing is that the function value should be maximum or it should be absolute minimum within that interval. So we'll now find the value of the function at x equals to the critical number, which is 0 for us, f of 0. F of 0 is equal to, we'll substitute here, absolute value of 0 minus 16, which is plus 16. So this is plus 16 for us. Now let us find the boundaries. Boundaries are at minus 10 and plus 10. So at plus minus 10, we are going to get the same value. As you see that part, they are similar, right? These are similar parts, which is absolute value of 10 squared minus 16, which is absolute value of 100 minus 16, correct? So that becomes the value. Let's do it. So we have 100, take away 16 as equal to 84. So this value is 84. So within the closed interval, what we get here is that 10 will be somewhere there, right? So it'll be, let's say this is, let's break this a bit. So let's say this point corresponds to x equals to minus 10, and this value corresponds to x equals to plus 10, and that value is 84. So what we get here is that the absolute maximum is at plus or minus 10 and the value is 84. So the absolute maximum value is 84, which could be at plus or minus 10, which is at plus and minus both the boundaries. And absolute minimum is at undefined points where x is plus minus 4, and oh, I didn't check this, so let me write down that value also. F of plus minus 4 is equals to, if I write here, absolute value of 16 minus 16, which is 0. Now if you compare these three values, what you notice is that the minimum value is at plus minus 4 and it is 0, right? So we have a local maximum local maximum at 0, 16 is not the absolute maximum or minimum, right? So that is how you can answer this question. Remember, in some books we say that the function, when we are talking about extreme values, should be differentiable, right? So you know, sometimes some books may say that since the function is not differentiable within the given closed interval, we do not have absolute maximum and minimum. Well, I go with this solution. It should be either differentiable or the limit could be, tangent, vertical tangent, as it is in this case. So we actually go with the function should be continuous in closed interval. All right, so absolute function is kind of like this. So it does have an absolute minimum value, but it is not differentiable at that vertex. So we go with this definition that the function should be continuous in the closed interval, and then you compare critical numbers and the boundaries value and figure out which is absolute maximum and which is absolute minimum. I hope that helps. Feel free to share your comments and views, and if you like and subscribe, that'd be great. Thank you, and all the best. Keep posting questions like this.